So these two are different terms, and you should be careful with evolution of Earth's crust and evolution of Earth. So without wasting much time, we'll get into the topic. See, billions of years ago, nebula, a star, was exploded, and it has formed into our planets. And when it was exploded, it left with some kind of dust particles with minerals, metals, and all the things which contains silica, oxygen, nitrogen, all the minerals, gases, everything is contained in it. So after evolution of this explosion, our Earth and the remaining planets slowly gets evolved. Due with the huge explosion, these metals and these rock particles got spread over the space, and due to time passing of time, they got accumulated like this, and they started surrounding the sun, and slowly they got get accumulated like this, and they form into a planet. So due to this explosion and this revolution, all this kind, our solar system got evolved. So we'll see what are the systems got evolved. See, here you can notice these are the asteroids. We call these as asteroids. This is a asteroid belt. This is the asteroid belt. And so first Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These are formed. These are huge density planets, and these are less density planets, because this mainly contains gaseous. Due to revolution around the sun, due to, I can say, centrifugal force, gases spread long distances, and heavy density particles got accumulated near the sun, and they formed into this Mercury, Venus, Earth, and Mars. So this is the formation, and now we'll get into our topic. See, this is when we cut our Earth into a part, a piece of part is taken from the Earth, then it will appear like this part. So today we are mainly considering only this part, mantle part. The remaining part we'll see in later classes. This is the important part today, which we are going to discuss in very detail. So what happens is, due to formation of Earth, the mantle portion, this is the mantle portion, have gone into great I can say fractures, or great numbers of asteroids came and hit the mantle portion, and it got into molten stage, and it has undergone different kinds of changes, and it took millions of years to get cooled down. So this upper portion got solidified due to the passage of time, and this inner, we can say, this is the still in liquid form. So now you get an idea about what is the mantle by seeing this picture. Now we'll get into our topic. So our topic is origin and evolution of Earth crust. Origin and evolution of Earth crust. It is not same as the origin and evolution of Earth, which I have explained earlier. It has been a matter of great debate, because we don't know when Earth got evolved, and there is no better prediction, or there is no scientific proof how Earth got evolved. So this is a great matter of debate. Large numbers of scholars came with divergent views, like we can say Kelvin, Soles, Chamberlain, and Moulton. They came with different kinds of views, but none of them are scientifically convincing. So the process or beginning of Earth crust is associated with the origin of planet itself. So the formation of Earth crust, which we have seen, this portion, mantle, this began with the formation of planet itself, which I have explained earlier. So the process of gravity collapse, due to centrifugal force and gravity acting on it, the broken parts or rock minerals got accumulated and they formed into a large planet. This is the planet. So the process of gravity collapse that differentiated the interiors, creating the first crust of the earth. This is what I have explained here. Due to gravity, there is a formation of a first layer of crust, and it was very thin, fragile and brittle. Initial stage, it was very thin and very fragile. The crust must have been subjected to repeated fracture, which I have explained in earlier, that due to asteroid or meteoroids, they went under repeated fractures or sudden impacts, and this meteoroid impacts in absence of atmosphere. The initial stage, we don't have atmosphere, so this is the initial time. The fracture of earth crust would have repeatedly recycled the mantle rocks, the upper portion of rocks, due to the repeated recycling or repeated attacks of meteoroids and partial melting due to the falling of meteoroids on the surface of Earth. It has undergone different changes, and it might be created the first oceanic basalt. That is due to those kind of meteor attacks and partial melting and all this kind of thing. It has started creating the first layer of oceanic basalt. This is the oceanic basalt which I have created, and this oceanic basalt, due to after the formation of Earth, atmosphere evolved, and there is when meteoroids fall on Earth, they brought water particles with them, and those, I can say, these meteoroids which we see these times, one or two meteorites come and falling on Earth, is not similar when Earth was formed. It was like a huge shower, how rainfall is occurring. The way the meteorites were fall on the Earth, they brought water particles with them. So these water particles, and our Earth is in molten condition. These water particles, like ice cubes, they, when they fall on Earth, they got melted and they formed into water, and they emerged on the Earth's surface. So thus the ocean or sea is formed. So that is the first oceanic layer formed on the Earth. Next, the primitive crust. This is we are considering as this is the crust layer, and this is the oceanic crust, full of oceanic crust. This is the ocean crust. Let me change it. This is the oceanic crust. So due to weak force, or due to the revolution and rotation acting on the Earth, this molten or this partially melted layer will get into a change, and they start moving, and sometimes they move apart from each other, and sometimes they come on the same direction and they meet, and these rock materials or this molten material or this crust, we can say, is not same everywhere. The density of the material changes layer by layer, or I can say now if we consider the current situation, continents are having lesser density and ocean crust is having higher density than continent. So this will be the changes, and due to this kind of changes, it has undergone numerous change, and the first stage is the primitive crust, formation of primitive crust. Here what happens is, due to some force acting on it, these plates move towards each other. I can say this is due to compressional force acting on the plates. These plates move each other. So in oceans also there will be different kinds of density. Ocean plates will be having different density. So if you consider this is of a low density and this is of a high density, so this will float on the lower density. Sorry, this is the higher density and this is the lower density. Lower density one overflows on the higher density. This higher density plate will get subducted, and here we'll see below the mantle portion there is a molten stage. This is the molten stage. Which means here whole plate will be in liquid state with huge temperatures, high temperatures, with high temperature. So what happens here, due to melting and accumulation of this subducted plate, here we can see formation of lava, and this due to upliftment and due to the movement of earth, or due to the movement of I can say these plates, it forms into a volcano and it gets exploded and it flows like this. In next figure we'll see this. See, due to the mantle, and this is the partially melted crust. This is the partially melted crust. This is the mantle portion, and this melted crust will result into formation of basalt, that is due to, I can say, volcanic activity. So here, due to compressional forces acting on this, and here there are divergent forces acting here. So these kinds of lava, or I can say fold mountains, are formed, which results into the formation of basaltic plateau, or simply I can say formation of islands. So in next figure, this is the origin of basaltic ocean circuit, ocean current crust, and this is the origin of volcanic arc. See, here the subduction plate, due to subduction melting takes place, and this due to melting this will get to reach the upper layers of the crust, and it forms into the island, or we can say mountains kind of thing. And this, due to water, presence of water, this gets solidified here and this forms as an island. This we call as andesite rocks. So the next is origin of ancient nuclei of a present continent. So after the formation, here we will see, after the formation of this kind of andesite rocks, due to the compressional forces acting on both sides, compressional forces on acting on both plates, this gets into the open place here. This will get into a fold mountain, will form as a fold mountain like this. This is the fold mountain, and which forms as a continent later stage. So here the main, we have to think about time. This will not happen in single day or 1 or 2 months. It will take some million years or thousands of years to get evolved into this planets and continents and oceans. So this took millions and billions years to form, and which we are enjoying today as the unique planet in the solar system. So the recycling of the ocean basalt due to the thermal convection must have created the first andesite rock, which I have explained there. First andesite rock, due to recycling, and see here, this is the recycling process. Due to recycling or due to the formation of due to melting of this subducted plate, formation of andesite rocks takes place. This is due to volcanic activity. Microcontinents, that we can say as microcontinents. Numerous microcontinents must have collided and fused to form the first supercontinent, Rhodina. Initially, we say this as a Rhodina in the pre-Cambrian times. So, which have explained earlier, these andesite rocks, due to some compressional forces or due to the cyclic movement, they formed into the supercontinent. This we considered, if we consider this as microcontinent, this is after formation of this is the supercontinent, or simply we say it as Rhodina. Continents when formed would resist subduction. So continent will not undergo subduction due to its lower kind of density. It will float on the higher density kind of plate. So continents, once they form, they will never undergo under subduction, but they can form into fold mountains, but they never undergo into the subduction, and they never forms any kind of lava or any kind of volcanic activities. Through the Paleozoic times, Rhodine splits and fused again to form Pangaea. So what happened is this small kinds of island or micro continents, I can say. If we consider this is our Earth and this is the equator line, so some parts accumulated here and this formed into major continent, and some part accumulated here and this formed into major continent. This we call as a Rhodina in pre-Cambrian age era. Pre-Cambrian era. Due to evolution of time and after millions of years, that Rhodina got evolved into Pangaea. That means due to movement or due to circulation taking under the mantle, or due to circulation taking under the crust, and due to the formation of volcanoes and the forces which we have discussed in yesterday's class, those affected the formation of the crust or the layers, and those brought down all the microcontinent. This we consider as equator, 0 degrees. So those all micro islands got accumulated here. Those micro islands got accumulated here, and this formed into Pangaea. This formed into Pangaea during the Carboniferous and Permian times. Pangaea again broke during the early and mid Mesozoic time into Laurasia and Gondwana land. So this huge continent, due to forces acting in it, or it again broke. It again broke here, and it started moving towards northern side, and some parts started moving the western side. If we consider this is the western and this is the northern part, this is south and this is east. So some parts started moving on the northern direction, and some parts started moving in the western direction. So due to this split of Laurasia and Gondwana, now we are experiencing the continents which we have in today's globe or today's Earth. We can see it in Atlas. So I will show you how the continents, I can say it as how the continents moved apart and how they settled. All of this explains how oceans and continent interact through the process and mechanism of plate tectonics. This all forms a part of plate tectonics. We'll discuss this in our coming classes about plate tectonics. This is a large topic, a huge topic. So this will take a minimum 1 hour of class. So be patient, and it will be interesting class. So I will draw the map. Those who are preparing for UPSC, map is mandatory. Drawing maps will give effect to your answers, will give good impressions. So maps is the important part. Start practicing maps from day one itself. So this is the planet Earth which we see today. So this is how our continents got evolved from this Pangea to which we are seeing today. So you should make this map. It will be very interesting to learn how to make a map. So, and it will give you a better impression to your answers, and it will help in gaining you more marks. So please start practicing maps, India map also. It will be a benefit to you. So if you feel that you gained that you gained knowledge from today's class, so please subscribe and share.